Hello everyone, I'm Jiayi. Here is my presentation of homework 6, question 1. Now, let's look at this question 1. Firstly, we're given that the probability joint density function of x and y with a constant a is this. Now, we will use this information to index some properties. The first problem is to get the value of a, so we can have the total joint density function. We just use the basic probability property, which is integral of density function must be 1. This integral of joint density function must be 1, so we can calculate the a, and the result is 4, right? So now we have the total joint density function. And then we need to know that if the x and y are uncorrelated, we can calculate this by calculating the correlation coefficient, which can be calculated by the expectation of x and of y and of x and y. So we first calculate this value, and we got that the expectation of x is 0, of y is 0, and but the expectation of the product of x and y is not 0, is 1 to 9. So they are not equal. So finally the correlation coefficient is not equal to 0, which means the x and y are not correlated. Also, if the x and y are not uncorrelated, they are not independent in most instances, but we actually need to calculate it by the joint density function and the marginal density function, the product of them. Just calculate, use the integral, we can get the x marginal density function and the y marginal density function is, both of them are half. So the joint density function is not equal to the product of two marginal density function, which means x and y are not independent. Okay, now we come to the first question, which is we need to find the joint density function of x squared and y squared. In this question, we firstly assume two new variables to represent x squared and y squared for convenience, which I use as u and v. This, and then we calculate the derivative of each situation. There are 4 situations, absolutely. So we can easily get this R. So we can use the formula to calculate the joint density function of the new variable by this, and the result is this. So the first question is this. And finally, to prove that x squared and y squared are independent, we can calculate that whether the joint density function is equal to the product of the marginal density functions, like what we do in the third sub-questions. So we calculate the marginal density function of u by integral is this, and the v is this. And we can see that the joint density function is equal to the product. So the x squared and y squared are independent. Okay, so that is my result. This question is done. Thanks for watching.